Welcome to the Weekly Dev Sprue. Today we're diving into the future of web performance with who else but Ryan Carniato, creator of SolidJS, CEO of Signal, generally JavaScript performance enthusiast, and generally just a great person. So I'm very excited to talk to you, Ryan, today. How are things going?
Hi, thanks for having me. Things are going pretty good. Things are being pretty great, I have to say.
You do have like little dark circles below your eyes. I have an idea how this can be, but let's not talk too much about that, even though maybe let's talk about that later on a little bit, because I have some questions. I love what you're doing with SolidJS and Signals. You have basically spread the good words of Signals throughout the entire ecosystem, and now everyone benefits of that. What I would like to know, though, is what motivated you to start SolidJS in the first place? Because like at the time when you started SolidJS, it felt kind of like web is done in a way. Like, right, there was Vue, there was Angular, there was React. I would need to look through Wikipedia to figure out if Svelte or Solid was first, but you know what I mean, right? Like there were already established players in the field. So why did you sit down and be like, you know what, we need another framework?
Yeah, I mean, it's one of those things where like everyone has opinions of what they like and certain patterns, and they kind of like, sometimes it's something very close to when they got started, and then, you know, things change or evolve, and then they have some nostalgia for the past. And for me, I've gone through that cycle several times now, actually. And because I started web dev like back in the mid 90s, like I was building like early teens, I was building sites for my band and other bands and local businesses. And it was like all JavaScript, right? You know, before everything went to server, you know, heavier server side stuff. But anyways, jumping way ahead, my favorite pattern for building UIs when I first got back into JavaScript after, you know, spending a bunch of years in ASP.NET and Ruby and all that stuff was I came across a JavaScript library called Knockout.js, which was based on signals, basically. They called them observables, but not to be confused with RX observables. These were signals, essentially. And I just love the pattern. It just fit how I thought about things. And I don't know what this comes from. Maybe it was my background. I used to do like game dev stuff, you know, as like kind of like a hobby. But actually the biggest comparison is something that I like quite enjoyed was hardware modeling, like FMPGA boards and stuff, like digital circuit modeling. And there's something about those systems where you describe the state of the system and there's no real sense of time. There's a clock that ticks, but there's no before and after. The clock ticks and everything applies at the same time. And then the next state. And for some people, this is really hard to wrap their head around, because it's like, it's not your typical like grocery list programming thing where it's like, I do this, then I get this, then I get this, and then get this. It's like, you have to build the system in such a way that every state of the system represents the truth. And I loved modeling problems like this. I didn't really realize it, but when I found Knockout, even though I built web UIs with it, I'd make games with it. I'd make like Sudoku puzzles and little demo apps and little things. And I love solving problems like, say, form validation, because I could just set all the rules up and everything would just like, I knew confidently that things would reflect the rules. And Knockout had this ability with its signals implementation, and I quite enjoyed it. And then React came, and React was like, no, state isn't persisted. You just come through and throw everything out every frame. And in a sense, there's a consistency guarantee there. But for me, it always felt very imperative. Like, I do this, then I do this, I do this. I know they tried to like sell this declarative thing with their JSX, but the declarative thing was an illusion. And essentially, I really like this pattern. And since React, everyone had basically abandoned this approach. Technically, Vue still had signals under the hood, right, in their options API, but they did everything possible to hide it. Like they're like, we're just dealing with plain objects, just like Angular. But they weren't, but you know what I mean? Or React. And essentially what you had is all these kind of re-render consistency-based models, immediate mode in graphics versus retained mode, where there's this idea that, you know, it's like FPS. It's like, I'm just going to re-render our scene or our component. And as cool as that is, it just never sat right with me when I saw like Ryan Florence from like React Router Remix fame being like, this is way faster. He did this demo with like a stock ticker, where it was like he showed Ember, Angular, and React obviously killed everything in this demo because he was basically spamming the page with a full page worth of data and like using the diff. And I'm like, that's not, at least in my experience, that wasn't the real world. I was working on social media apps. Like I was working on kind of like an Instagram for schools kind of thing. / Google Photos is a little bit more, and it was like private. We do like facial recognition stuff. It was like, so we could sell photo products to parents. It was this whole kind of private school for school kind of project. And I wasn't stock tickering my app. I wasn't like, that'd be really inefficient to pick the whole state and then diff it every single time. Yeah. We did a lot of interactive stuff like drag and drop grids and like multi-selection and, all these filters and stuff and big tables. And I was using Knockout at this company. And like when everyone's like, let's React in this model, I'm like, how couldn't this possibly be more performant? How could this be a better model when you're doing all these little changes and UI users are interacting with all these little pieces? They're not like sitting there going, okay, API, spam me the whole page's worth of data, at 60 FPS. So every time I tried React, it like just didn't sit right with me. And then what was crazy to me was, other projects started following suit, right? Like, I don't know if Vue 1 had a virtual DOM, but by Vue 2, they were definitely, even though they had the React assistant, they're still feeding it into this virtual DOM. And, Angular, I think they did a lot of work to try and make their dirty checking less expensive, but the original version was like, I think more fine-grained. I think they actually like went more streamlined on component level stuff. And it was just like this whole shift away from the chaos, but also away from what I felt was a legitimate alternative model. So around 2015, React was already kind of on its deathbed, so to speak. I was just like, our company was still using Knockout, and I was like, Knockout needs like a kick in the arm modernization. Knockout was slow because it was doing all its binding. Have you seen Alpine.js at all?
Shortly. I feel like it was like 2014, 2015. It was like, well, Alpine.js is the new shit. Knockout is on the way back. Amber is really cool. So I feel like I've seen all those headlines, but never played with Alpine.
Alpine was a little bit later. It came out in 2018, but what it was like a throwback to the old way, like Vue 1 or Knockout kind of thing, where like, and this is the reason I'm mentioning is what was specific about Alpine and what Knockout had was that you'd actually write your bindings in the HTML. So you'd actually just have an HTML file, and then you'd be like data bind equals, or you put some syntax in the HTML. And in some ways you might be like, that's not that different than Vue, like V4 and all this. But the difference was Vue pre-compiled it, like their templates, where these guys literally took the HTML as DOM, like it turned into DOM elements, parsed the string attributes out of the DOM elements. Like, so like if you had a template, like you're repeating or had a conditional, you'd actually like briefly render it first before you'd remove it and then repeat it or something. Like this is the kind of tech. And I'm like, signals are better than this, right? Like we can modernize this. We can use modern tools. We can use modern syntaxes, and it's funny, I didn't even like JSX originally. I was like, I didn't set out to use JSX, but then like as I was working through the problem and doing different data binding, I was like, I started really liking the portability, like how you could just build a piece here, kind of stick them all together. It was just like kind of composable template piece. But I like the tooling had jumped light years in, from the compilers that we saw at the time in Vue, and I guess Angular, this pre-Ivy, and to even like just the build bundling tools that we saw in React, the Donna Webpack, all these things, so many things had changed from Knockout. And people were just like, oh, this is some old tech that isn't good. And I was like, yeah, something I just didn't believe. I'd see these benchmarks and these tests. I'm like, this doesn't make any sense. This approach doesn't do work. So how is it slower than all these approaches that like do a ton of work?
I have to say with this like speed comparison at all times, I feel like this is to some extent an artificial conversation. And I hate that to talk to like the performance guru and say that, because I feel like the thing is like everyone is super focused on like performance, but at the end of the day, most web applications are basic CRUD applications. Like if we talk about like really enterprise, they're like displaying a data table and doing like fancy Excel stuff. That's most what business applications do these days. So are we really talking about performance limitations? Does it really matter? I don't think so.
Yeah, I mean, it's interesting because there's a difference between like how fast can I update this text box, and there's a difference between architectural repercussions of performance. Like,
oh yeah, 100% agree.
And like the thing is, the problem is like the first category is what people do when they go, oh, I want to benchmark this new framework or library. They put like a text box on the screen and see how fast they can jam it. And luckily Solid, for example, and Signals does amazing at those tests. So everyone's like, oh, it's really fast. But it's like, that's not why. Like the part that got to me was, as I told you, I was making these large data grids and stuff. And if you have data being injected from above, you know, the one thing that's actually really special about Signals isn't the signals themselves necessarily, because like the signals are immutable. They're just like these data atoms. For people, I don't know how familiar this audience is with signals, but like they're like the only difference between like the way a signal does an update and say React or a virtual DOM library does an update is the like granularity, where in those libraries they're like, look, you have components and we control the granularities. Like we'll rerun X number of components. Whereas with Signals, you're like, look, in your hands, you have all the separate atoms. You can run these independently or not. So like you have that control. But if you just like do something really coarse grained, really dumb, like you're just like, I have a bunch of signals, but there's only one effect or one thing running. Well, it's no different than a virtual DOM. It might be worse because you don't have a virtual DOM to absorb that cost. So like you're essentially just rerunning things like on an event. It's people seeing, they're like, oh, what's the difference between this pub sub and where? Obviously, there is a difference because with all that granularity, you can get chaos. And what evolved in Signals over the 2010s, which was off screen, so to speak, like you saw it a bit with MobX with React, but what people didn't realize what happened from knockout till time Solid came out was that we started coming up with better, smarter algorithms to make sure that the data propagated once, that there wasn't cycles, all these kind of guarantees. But the thing that's interesting about these fine-grained approaches isn't just about the way you can like disperse them. I mean, that's good because it keeps things independent. It's that you can nest them. And a lot of times, I mean, this is a big thing that Vue brought forward with their proxies. And one of the reasons I actually built Solid over Knockout, because I wanted better proxy support, is that when you have proxies, fine-grained nested reactivity, you can inject data fairly high up, some shared store, something, and you can have it flow through your application, through those data tables, through those whatever, grids, whatever thing you're building. And when you update one little piece of data in that nested piece, that's the only part that needs to go. Like that means you don't have to rediff the list. You don't have to check if those 10,000 rows have changed, because the reference for them are the same. They actually haven't changed. It's mutability. And I think that while you're never going to see that very often in these benchmarks that have been sensationalized, like over the years, the thing is this lack of like, I'm just re-rendering. Like the problem is a re-render model in one sense has a fixed floor on performance. It's only as bad as re-rendering the whole app. So something like React had this benefit that like we raise the floor. We know that with a virtual DOM, it can never be worse than like our worst, right? Whereas you don't know that in a lot of previous systems. The DOM's more expensive than a virtual DOM from the creation standpoint, so you don't want to keep on recreating it. But on the other hand, it gets very quickly out of control if one thing starts re-rendering and then other thing re-renders, and now you're triggering triple or quadruple re-renders. You get to a point where you're like, and like React developers will know this because they're familiar with this problem. It becomes incredibly hard to figure out where in the tree stuff is causing this re-render. And eventually you might like go, okay, it was 12 re-renders. I've gotten it down to 3. That's probably good enough for now. I don't know where this is coming from, but then, something later, someone adds a feature and it goes back up to 6. Or then like you get into this kind of zone where it's just like the slippery slope where it's like, who poked the bear, so to speak. And I feel like when you start from the opposite angle, where you're just like, look, almost nothing reruns, only the things I want to, it's much harder to get into that kind of state. It's also much hard. Sometimes what the downside of this is like when you do something, your app suddenly breaks immediately and you're like, oh crap, what did I do? And you have to fix it right then. Whereas if in the other model, if your app, maybe should have broken, but it doesn't, you'll just re-render 3 or 4 more times. You won't notice it. And then you won't notice it till it renders. It's now rendering 24 times when it should be rendering once. And you don't notice it till then. So it's like there's this kind of architectural consideration that comes in. And as I said, it's not purely performance. The reason that I was attracted to the patterns was because the way you could model problems of these kind of declarative set of rules. So the performance is tied to it. But when I speak of performance, it's in the more general sense.
It sounds more like an added benefit for you than really like the main driver for like reinventing.
Right. and to be fair, like there was a movement in there were people still pushing signals and these kind of approaches in the mid 2010s. They weren't popular, but there was a community of small community developers. So when like React released React hooks in 2018, a certain number of them were just like, oh, I guess my work is done. Like it was the composition, like the way hooks, you could just build up these and the composables in Vue and all this, so you can just build up these primitives. That's what everyone was, a good number of people were looking for. When React released hooks, even though it wasn't the same, they're just like, this is all I wanted. I just want an ability to declare some state, derive some data, and you can kind of treat hooks that way and, have kind of a sort of version of this. But what I saw at that point was what accelerated Solid, because I was like, wait, our version's like better. Like that was the thing. And I wasn't the only one who saw that. Evan Yu, from Vue was like, we should just pull out our composable primitives, like get them out of those hidden objects. So like the composition API, Vue 3 came out like because of React hooks, because React had dominated that conversation. Everyone was afraid of doing something more complicated than React. When React said hooks are the way to do it, everyone's, all the reactive libraries are just like, I already have better version of hooks. It's go time. Even Svelte, like that's when Rich Harris was like, wait, we're a compiler, like at first he was like, oh, we can add hooks to Svelte. And then he was like, no. Once he like wrote it out, you could tell he had like tweets, like literally the day after the original talk, where or within the first 3 days, I think he went like, he posted an idea of Svelte with hooks. And then he was like, wait, I'm going to just use the compiler, and the whole Svelte 3 rethinking reactivity thing spawned from it. So it's crazy how an event like the announcement of hooks, that's why the date's ironed in my head. It's October 26, 2018.
Jesus.
Yeah, because it had such a profound impact. Like I was already doing the thing with signals and JSX, but then like Dan Abramov walks on stage, and the first thing I saw when I looked at the code was, I'm like, this looks like Solid.
That's one thing that always surprises me when I look at Solid code. I've not written a Solid application, but I'm like, yeah, okay, I can read this. I could not write it because I don't know of like the corner cases and stuff, but I can totally read this.
Right. So understanding this, like 2015, 2016, I was building, started the ideas. I started closed source project. I was hoping to replace some of my work. And, I was building benchmarks. This is why performance became a thing. The reason performance became a conversation is because that is also how React killed Knockout. It was benchmarks, essentially. Like there's a bunch of things like when you have something kind of arbitrary, like there is a whole like Knockout didn't have all the guarantees of reactivity that we have today in terms of run once, glitch free, all that kind of stuff. So there was chaos. But when they kind of came out, you say that to people liked what they use. You have to actually give them something more than that. And React was like, no, like the performance isn't good, blah, blah, blah. There's all these characteristics. And I was like, so I had to start from a place that I could actually do it. So obviously I looked at the benchmarks that were out back in the day. I made like the circles. I looked at JS Framework benchmark. I looked at Ryan Florence demos, all those like VDOM demos. I remade them. And I was like, can we be as faster? And the answer was yes. Stores, that the granular reactivity, if you can diff the stores, diff the data instead of the view, you have the potential to be very performant. And this, again, maybe sounds specific, but I needed to vet it. So performance was my starting point because I already liked the patterns. I needed to prove it. So by the time that I released Solid publicly in 2018, early in the year, before the hooks thing, I was like, it was actually to go in the benchmarks. I was like, okay, I want to publish in the benchmarks to show my findings, right? I wanted to like prove that this approach was good, because I didn't think anyone would like it, because at that point it was like I have these like primitives, almost like these, we call them composables or whatever. I had these like, like the signal, the computed signal, and an effect. I had these three primitives, and I thought no one would want to write code like that, because everyone was like insistent that you have to use plain objects and basic stuff. So I was like, okay, no one's going to use this, but look, it's fast. And then 6 months later, React's like, you should use patterns that look like this, and I was like, what? So I at that moment, I knew like my life was going to change. I started educating. I was writing pro React hooks articles to kind of convince React developers to use hooks. I was writing articles about like, there was a lot of good stuff to learn from React. For me personally, I had this show that you could take those lessons, all the complaints, all the things that people over time dismissed about signals, also applied to signals, except signals could do more. And that, for me, that was an education thing, because nobody knew who I was, what we were doing. When I released Solid, no one really cared. I didn't have a following. Like Vue, Evan had the benefit of having worked for Meteor before. Svelte, Rich Harris had his own reactive framework before that called Reactive, which was it was actually kind of knockout-ish. So these guys had already kind of established it. I was this guy who's coming in and be like, look, you can write JSX with like fine-grained primitives, and it's super fast in this. And the response was besides people going, why the hell another JavaScript framework? People just literally not believing what I was doing was possible. I remember when I joined Twitter in 2020, and I would like post stuff, and I just like put it out there, like, because there's some, like someone would post something like big, maybe like Rich talking about why Svelte could never use JSX. And I'm like, well, Svelte could use JSX. Here's like an approach or blah, blah, blah. And, I had all the people coming out of the woodwork being like, this is impossible. And the React team tried this. And that's how I met Dominic Ganaway, creator of Inferno, and who's responsible largely for Svelte 5, to reactivity and Svelte runes. They were flagging him and being like, look, this guy says he could do what you couldn't do. And Dominic's like, no, it's perfectly fine. This isn't why React didn't go this way. React wanted its concurrency. And, but it was just crazy, because people didn't believe it was possible in 2020. I remember I reached out to Evan at one point when Vue 3 came out. I think it was again 2020. And I was like, hey, like, you have all the pieces here. Why are you still using a virtual DOM? And he's like, oh, because we need it for this or this. And I'm like, I don't think you do, but like, do check out this project, see if it's interesting, right? And now 5 years later, we have Vue Vapor.
Right.
But like, it took a while. It took 2 or 3 years there of just like, I almost felt, as I said, I had to teach these concepts, because people didn't believe it was possible, didn't believe the trade-offs. We'd been so ingrained from a world that was dominated by React that it was hard to like trust that stuff could go a different way. That's why when Angular picked up signals finally, I say finally, but for them it was a few year process, but given the size of Angular, it's not finally at all. It was like actually surprisingly fast. It was like a lot of validation on a lot of the work that we'd been doing with the Solid community, because it was like, these guys see it and they believe it. And that's the thing. We won over framework authors first. We like nerd sniped every single framework author. The general masses of web developers could care less. They probably still don't get it. Like, oh, it's an event system. It's like, and adding signals doesn't just make your stuff faster. It's actually another system on top. It's like adding state library to React doesn't make React faster. It might let you write faster React code, but I can take core React and write something faster without a state library, because a state library is this extra overhead. What the power is if you have this piece in place, you can remove other pieces that don't need to be there. You don't have to have a virtual DOM. You don't have to have these other abstractions, which ended up, as I said, giving us interesting trifecta of being both smaller and faster, which is something that hadn't happened in a while. Like even things like Preact, which are smaller, weren't noticeably faster. So like there's this, and then there's Inferno, which Dominic's library, which was faster but not smaller necessarily. It was smaller than React, but that isn't a hard target. But like we kind of got to this place where an interesting convergence was happening of these ideas. So like it's been, very, very exciting for me, and to see the kind of community grow from it. So the impact of Solid or our work Solid probably is more felt to people through other communities, when they see stuff like, Svelte runes and Svelte 5, which is basically very similar to Solid's approach. The Svelte went from like a compiler that was like always build time, looking at analyzing dependencies, to a runtime system with fine-grained updates like Solid, View Vapor. When you start seeing the impact of all these libraries picking up signals again, it was largely related to the work and the education that we were doing, which is funny because those numbers way outweigh the number of people who actually use Solid directly. So it's interesting because we find ourselves in a very different world now in 2025 than maybe people would have expected, with almost every major framework other than React itself having adopted some parts of this technology. And it's not just the technology, largely with the intent to move further towards in a direction that's similar to Solid over time. I'd said Vue and Svelte have actually basically become the same, under the hood, the same thing. But even like when you look at the kind of optimizations that Preact was doing with signals, in terms of they don't just use it as a state library. They have places where they can update fine-grained single VDOM nodes, in certain situations, and Quick use a similar optimization. This is kind of like completely changed the conversation. Sorry, I skipped Angular for a minute, but they're going from their dirty checking wide range to hopefully over time getting to more granular updates. And it's so it's so funny to kind of see this progression and see the impact this has had, as I said, for the community. And I guess I should mention, part of the reason that this is happening, for people to know, isn't just because of the arguably better model and the performance. It's because it unlocks new future capabilities. Like Angular team is interested in this, and Quick was interested in this because of they wanted to get resumability. There were projects like Wiz at Google which do resumability, this ability to like only execute partial parts of the page and only even load the code for partial parts of the page. But I mean, how do you manage that? You can do it manually, which is what Wiz was doing. But the easier way to do it is, what if you understood your code as a reactive graph? What if you understood like which parts of your code depended on other parts of your code? You can model it that way. That's how I ended up at eBay. In the middle between me working on my startup that I was doing there and to where I am now at Sentry, I actually worked at eBay for 3 years on their framework. And they actually, even though I've been known for signals and reactivity, the reason they hired me was actually solving hydration. It was actually about we were working on resumability. This was like 5 years ago, but they wanted a solution very similar, and they read some of my blog posts, and they're like, it was actually them who saw it before I saw it. I was just explaining like, components are the past. You don't need components. Components are just a dev authoring time experience. We can compile all the components away. And they're like, yes, that's what we need to do. Compile all the components away. So like essentially, they realized that this granularity would apply to their problem space. And then I got thrown into the world of server rendering and partial hydration and resumability because of that work. So it's been quite a ride. Obviously, after a few years there, Solid picked up, and they're still working on those projects. Amazing work, honestly, very, very, very cutting edge, the work at eBay with Marco. But I got the opportunity, starting with Netlify and now continuing with Sentry back in 2022, to actually work on Solid full time. So that's what I took.
I love talking to you because you're basically giving like the whole history and like how everything fits together. And for me as a host, it makes this very easy because I just like, okay, let me pick up this piece. How do you feel like the open source aspect and like generally getting involved in the community changed your career as a whole? Because I mean, you drop big names with eBay, Netlify, Sentry. Those are all like, particularly in like the open source space, big players. But how do you see this?
It's one of those things where sometimes getting pushed out of your comfort zone like makes all the difference. Because I don't know how I got there, but coming into the 2010s, I told you I was working on like ASP.NET, Microsoft stuff. I was a like Visual Studios user, the kind of guy who like relied on the autocomplete and like used the IDE to look up all my docs, like never had to use anything. Visual Studios was my whole life, you know, except for when I had to go compile and I'd go get up and take a walk and come back. Even if it was a JavaScript project. But like what I'm getting at is I was lazy in the sense that I was just complacent with these tools, and I get how everyone can get some of those rut. It's not a rut. It could be a layer, a good place for productivity. But when I left that work and I was trying to find a new job, and I was wanting to get back into JavaScript because of Knockout. You know, I love Knockout. I was trying to find a company that would hire me in Knockout back in like 2010, 2011. I stumbled across a startup. And their test was in Knockout, which is amazing because he gave us a question to build this like simple app, and he thought that he was thinking you'd need like some almost components and pieces to kind of build up the structure of this. It was like a photo app. This is how I ended up at that startup that I was talking about. But it was basically like you'd have like a listing of pictures, then you click in, and then you'd show a single one, and then you could edit a single thing, and then you can go back. You just wanted to like get a bit basic flow to show that we can build stuff. And instead of like building a well-structured app, I realized that I could just build the whole thing in Knockout bindings, like write all the logic in the templates, and it made it way easier. And he just like he was just like, I need to change the test now because you basically circumvented the whole test by doing this thing. But what I was getting at is this was much more Wild West. It was a small team. It wasn't like when I was working. I used to work at a company called the Active Network, and it was a big .NET house, and I was working remotely part of it, and like it was just like a big company. This was like a team where there's like 5 of us working who would come into the office, and we'd like just like hack away, and like everyone did like 10 roles. It was a very small startup. It's funny. He was technically the COO, the chief operations, because he preferred to be on that side, on the product side, on the operations side. Like he preferred to be more on the like running the stuff side. But he actually ended up taking on the CTO role too for the technology stuff. He was the creator of a library called Knockback, which was a combination of Backbone and Knockout. That's why he did the test the way he was, because he thought you'd like need Backbone models. He wanted to make a full functioning MVVM thing. And I basically did the whole test in Knockout, just the view model. But essentially, this library, you know, I think it was popular for its time. I'm back having 1,000 GitHub stars back in 2010 was, you know, something. That'd be like having 10,000 GitHub stars now. So people knew about it. Like I remember, like I was surprised. I didn't realize he was the guy when he hired me. But where I'm getting to this is at a certain point, you know, we were doing stuff and I'd get stuck, and he would be like, I'd complain about lack of docs and lack of stuff, you know, because we're using our own open source projects. We built our own ORM in house at this place it's called Backbone ORM. You can still find it. That's where I actually got my start into compilers and ASTs, compiling JSON into different database syntaxes. You know, I get stuck and complain about the docs, then he'd have to go do it. And you know, I could tell he was getting frustrated. At a certain point, he was just like, "You realize, Ryan, you can just look at the source code." And I'm like, because I was used to VS Code, like it being a black box. I was like, if you're wondering what the API is, you can just look. You know, it's not minified inside the Node or Bower modules, whatever we were using at the time, Node modules, whatever setup we had, a Gulp, Grunt, whatever, you know. And I was like, oh yeah. And it was like this like light opened up, and I looked and I was like, oh, okay, this is how this works. And then I started, you know, it brought me back to early JavaScript, because back in the late 90s, that's what you did. You just view sourced. And that's how you'd like, when you go on a website and you see something cool, no one minified back in like 97. You just like look at the JavaScript code and then be like, oh, that's how they do that trick. And you learn everything by looking at other websites. Well, I had that exact same feeling again when I was working for this company. So we supported our own open source projects. And then I don't know what to say, but I guess sort of like my mentor there over time, he kind of, I don't know if it maybe a bit of burnout or whatever, but basically kind of like fractured from the company. And I'd been there for a couple of years, and I took over, and which meant I took over all these open source projects, right? And that he had been building because he believed in that. And I'd learned, you know, how to read the source, and he'd start us kind of on a path, like he was guiding, where I'd basically made the next version of our internal framework, which was, it was a combination knockout of web components. And I basically had my hands in it now. So I was like maintaining this thing, and now I was in charge of it. So I found myself thrust into open source from a guy who didn't want to look at the source code to that in a couple short years. So by the time, 2015, I was building solid stuff, I just taken it for granted. I was like, look, I can find libraries, I can look at code, I can learn. And I was basically just fully all in on open source from that point on. And it's been beneficial because obviously the work with Solid, got out there, gave me a vehicle to educate and all that stuff. But it also took an important part of even the whole process of how I've started finding other jobs and stuff. Like my whole career since then, I have basically worked in open source since leaving that company. My roles have been pretty much like, at eBay, I was working on their open source framework, right? The thing that they published externally. Netlify, I brought on as an open source guy, not just to work on Solid, but to support open source efforts. And then at Sentry, I get to continue this work. So basically, open source has been my whole work and life ever since then, which is an interesting place because it's not a place that you always can make money easily. Or, when I'm running Solid, I have to figure out how to fund it, make sure other developers work on it, but the ability to just have a community there and share code and share ideas is invaluable. That's how we can move faster. That's how one person, to begin with, it never ends with one person, can start snowball rolling and then bring other people on and actually test ideas and actually get things to where they are. Like if these things weren't open source, people wouldn't be able to just pick them up or just look at them and adopt or borrow it for their cases. Like it's funny, I built agnostic libraries, one's for web components, I have one called DOM expressions, which basically lets you take any reactive library. If you look in the JS framework benchmark, there's like 5 entries that are actually written from me because they're all based on the same underlying compiler Solid, but one uses Vue, one uses MobX, one uses Knockout. But the funny thing is a lot of times people just don't, but they look at it and then they build their own kind of project from it. So like, it's not just about the direct impact of being able to like use other projects and use that code directly, but just the sharing of ideas and the sharing of community, which makes it so powerful. And has been such a huge part of what I've done.
I love how passionate you are about this because like just the way you talk about this, I can really tell like, okay, you're super into this and super invested. But what I'm wondering, burnout on open source maintainer is not an uncommon thing. Are you sometimes wishing like, man, like a 9 to 5 sounds really good right now?
Has there been times for that? I don't know. I mean, it's interesting. Like ever since I made the switch from Active, when I joined that startup, it wasn't 9 to 5 because the startups push you, right? So even if it wasn't the open source aspect, and then like once I was there, it's just like I personally get a lot from caring about the problem that I'm working on. I need to solve problems always. Like I like puzzles. I like, sometimes I'll be just, walking down the street and I'll be thinking about puzzles. I have to be careful not to get hit by a bus. Essentially, it's difficult. And to be fair, a lot of people who are founders of companies have the same kind of bug. I remember talking to the CEO of Itagami saying, which was that photo app that I was talking about, and she was saying like in a sense, like she could never just leave it as it is. Like there's a reason that she works the long hours or whatever. She needs something to pour herself into, passionate about. And I think in a lot of cases, maybe not on a start business side, I don't care about those aspects as much, but on like a idea technology side, I have that same kind of fire. You find in startups, these people end up getting all attracted to each other, and grouping, and the same kind of thing in communities and open source and whatnot. So, yeah, I don't know. It felt natural for me. I used to play in bands. Bands were very similar idea where you're doing a certain amount of self-promotion. See, again, I was on the artistry side. I was a songwriter, but like there's still this aspect of spreading the idea out there, building the community and whatnot. It's interesting because like sometimes you can feel like you get stuck working on a single problem for a very long time, and you're like, why am I doing this? Like, why do I have to solve this thing, but to have the opportunity to work on these kind of problems, I wouldn't trade that for anything. Like sometimes obviously like my professional life, if I find a project I'm passionate about, I can do that. But like right now I'm kind of the driver of my own destiny, which is incredible. I mean, sometimes, maybe it's scary, but the other idea is like, when I think of the impact of say what we've done now with Signals and what we will do, it's just like, it's great. I get the aspects of like R&D outside of the academic circle, and it's not quite on the, I mean, sometimes maybe I wish it was more on the enterprise side where it gets some more funding. But it's like, I'm walking this very interesting line between, like being able to like be a researcher and being able to like work on the problems I want, and then being able to see these things come to life in practice where actual people use it. This is a weird intersection where you actually have both cutting edge research in an area, new ideas, interesting problems, and people right on the other side just ready to pick it up and actually use it for real commercial or products.
I'm wondering, because you brought this up with, if I'm not thinking about or I think about a puzzle and get hit by a bus potentially. How is the impact of like this way of thinking about things your daily life? I don't think I'm quite as passionate about certain things, but I do have those things that keep me up at night, and my wife can tell. Very easy. She can tell if I'm in the room, but not in the room.
Yeah, I mean, this is one of the hardest things. It's one of the things I had to really struggle with, because you're trying to set boundaries, and mentally it's still difficult for me. I had to actually set boundaries on time. There was a time period, especially when we first moved down to here. We're from Canada, but we moved to San Jose because of eBay, where Solid was picking up, and it was like every hour where the kids were not awake or whatever. Like once it's late night, there was an incredible temptation to just spend a little more time on it, push it a little bit further.
Yep.
It doesn't matter, social. Push another tweet, just whatever it took to kind of move the dial, because the last thing you want to feel like is if you're stuck in a place. There's always like things happen in waves. So there's always like kind of get stuck and then you push. So the more time you think, the more time you can put at it, the less stuck you'll get, and the more things will flow, and the better everything will feel. The reality is, time, things do just take time. The more time you spend doesn't necessarily equate to things moving. Like sometimes it does, but most of the time it actually doesn't.
Sad, but true.
So, the exercise of just doing other stuff, just being like, nope, the computer does not come out in the evening, like at all, period. Always difficult for me, because if your brain will go there anyway, you don't even catch yourself doing it. So yeah, this actually took a lot of restraint and a lot of patience on my wife's part and family's part, to find a better place, because there was a time period where it was not good. And as I said, people associate that often with like entrepreneurs and that, where they're like can't drop it. It can definitely happen to people who are very deeply immersed in certain technology art. I mean, I guess they do. The people associate that with researchers too, right? Like it's that same thing where it's hard to leave the problem. And I mean, sometimes you'll be, as I said, walking, and then you'll be like, "That's it." The thing that you've like been back in your head for like 3 weeks, and you're like, "I need to write this down right now because like the details are clear in my mind." How do you prioritize for that when like you have other things going on in your life? So yes, this is actually has been something challenge with. I mean, on the flip side, I don't think I've ever really been at risk of burnout, but on the other side, maybe I'm not always the easiest to be around.
One somewhat personal question I still have, and then we can switch back to tech. Do you have things you like to do in your free time that keep your brain busy and like help you not wander to those problems?
Yeah, it's hard, because sometimes I wonder if I just replace one thing with another thing. Perfect example of that is like one of our favorite pastimes is hiking. We love hiking, spending time in nature. It always was my excuse to leave the phone behind, or like get away from technology. And we travel to go hiking. Like all our family vacations have been hiking, and nice. Largely based, maybe a little camping, but primarily it's the hiking aspect. If we camp somewhere, it's because we're going to go hiking. Tricky part is because I've always had a very vivid imagination. Like it doesn't take much for my head to just go somewhere. It's one of those tricky things. I think my parents even knew. I know this is a little personal, but when I was a kid, I always wanted like a Nintendo system, and I did end up getting one eventually, but after like my friends did much later, and it I was so into it that I'd play at my friend's house occasionally for, maybe an hour or whatever. But then I'd go home and think about how I could improve it next time we played to maximize my time. And even when I got my own Nintendo, I got the magazines and I would study the Nintendo Power levels ahead of time to maximize my playing time. And I would go to sleep and I'd dream about the Nintendo levels and think about it. And that kind of thing is hard to change. So because what it means is no matter what the problem is, one of my favorite pastimes, a hobby, is another game called Magic the Gathering.
That's great.
Deck building and metagaming is again another problem where you can spend a lot of time thinking through these problems and but as I said, I don't know if that's really turning things off, right? I think the best exercise to turn things off are things that are repetitive and the problem solving, but they're repetitive. So things that are actually good at turning the brain off or getting away from that is reading books and puzzles. I love puzzles,
actual physical puzzles. Okay.
Yeah, because the puzzles aren't hard. But they require you, they can be difficult to do, but they require a lot of patience and they require a lot of trial and error and they require, looking around. They keep your brain occupied, but not in a way that is into that imaginative space, which is where I spend a lot of the time. I'm more likely to be able to focus on what's in front of me when I'm doing a puzzle, if that makes sense.
Coming back to tech, this was great, by the way. Thank you for that. I really appreciate that. You mentioned there will be big things coming with Signals. You said something like there are big things on the horizon. And if I remember correctly, there was a 5.5-hour stream about Signals 2. Be honest with you, I did not spend 5.5 hours to watch through the whole thing. So do you have a TLD watch?
Yeah. I mean, the thing is, as usual with the stream, I have to start in one place and build up to where it is. And I did a stream a year before that stream, which was when I kind of put the concept out there. I called it Designing Signals 2.0. And then a year later, I'm look at what we've done kind of as a concept, kind of proof of concept. The way I look at it is people talk about the pub sub aspect of Signals, it's an event system. And that's a part that's kind of gone everywhere. But the modern reactive libraries, there's really three pieces. It's not just the dependency tracking. There is the dependency tracking is one piece, the whole way that you can read and it tracks the read automatically and it does all that. But the other two pieces are the scheduler and the what I call the ownership graph. And before Solid and the talk of the scheduler was not something that people really talked about very much, and are not certain the scheduler. The ownership is what people didn't talk about much. Basically, the earliest reactive libraries had no scheduler and no ownership. Later on, due to the popularity of things like React, we started seeing scheduling getting into Signals. Vue is probably, I'm going to give credit for one of the first places where we see this kind of scheduling, where it wasn't just about pushing out the notifications. They'd actually schedule the work that it would happen to VDOM, in batches and stuff. But the big innovation, and we didn't come up with this, credit goes to a reactive library called SJS, but we adopted and kind of popularized it, was this idea that the reactive graph has a second graph overlapped with it. And what I mean by that is it's this ownership graph where not only do different signals have dependencies on other signals, but inside, say, a computed, you could create other computeds. So or other signals. So you could actually compose the graph, not just by aggregating a bunch of signals together, but actually by nesting signals in signals, second order reactivity.
Okay.
But the challenge with that is reactivity is an observer pattern, which means that it leaks. You have to link both directions, both to the observer and to the observee or whatever, the listener, and both sides need to link to each other. So if one exists, the other stays. You can't just make a bunch of stuff without it all, existing forever. And the challenge is, how do you manage disposal in a reasonable way? And back in the day, it used to be manual. Basically, signals didn't dispose, but effects would. The end of the chain would dispose, and some libraries had auto-disposed computeds, others made it manual. The big difference with this ownership graph idea is that at the same time, when you rerun a parent, we can assume that everything underneath that is going to be recreated so we can release it. So the idea here is that not only do we reset the dependencies on each run, we clean up any nested children. And while this might not seem very obvious to people why you'd need this kind of superpower, it was the basis of how Solid's fine-grained rendering ended up working, because what we basically do is we build a tree of reactive effects, and that's how all rendering doing. That's why we can do all the independent updates, and how we have a component model without components. It's not the rerun points aren't based on components, based on like your user code in a sense. They're based on decision points. Like if you have a switch that goes A or B, for it to be reactive, it needs to independently update. And if you have 10 components under A and 10 components under B, well, you don't need to make 10 different nodes. You just need to make the one node that switches between A and B. You might have other effects and things under nested, but this whole model of nesting and automatic release is what made Solid possible. And I kind of joked around for a while calling this Signals 1.5, because this was like a very important realization that SJS had and that Solid has. And libraries at that point didn't really do it. But you see now things like effect scope in Vue. That's an example of this. We call it create root in Solid, which is this idea of this nested ownership. Alien signals I just got a chance to look at for the first time last week. And they actually build ownership built in. So they are recognizing it as a first-class citizen. It's not part of like the TC39 signals spec, because people weren't sure, how they want to handle it, but they want to make sure that it's expandable to handle it. So that's what I call, as I said, like Signals 1.5. It's basically I started kind of joking what we launched on with, because when we released Solid, this was part of it way back in 2018. But as I watched other libraries adopt signals, they missed this piece at first. It only starts showing up when you build Vue Vapor, or when you build Svelte Ruins, when you start actually building these kind of hierarchical systems. So this kind of leads me up to what I started dubbing Solid 2.0, because I needed, or Signals 2.0 was because I was like, what's the next frontier beyond the ownership? And for me, there's two topics that are highly underdeveloped. And those two topics are async and nested reactivity. I talked a bit about proxies and stores earlier in the stream when I was talking about like that power that you don't get in a compiler or in like a React-like system, is that ability to inject deeply nested tracking state and like update one little leaf node and have it update one leaf in the tree and have it run through your whole program, because it's just signal and signal and signal and signal, essentially like these big proxies. The area that's very underdeveloped in that side is the idea of deriving data, because when you there's always the source, the signal, or the store, which is this nested piece, but then you want to use it. And the thing is, the normal derived value, the computed value, or in Solid the use memo, it joins the values. Like if you have you listen to 10 different signals in one computed and you get one value out, it's basically a merge, essentially, which is good, right? You might merge it in 10 different ways and have a bunch of different outputs all over the place. But essentially computeds are merging computation. And I realized that I wanted a forking computation. I wanted the ability to take something that maybe has multiple inputs or a single input and actually have it output into multiple different signals. And yeah, it's because certain problems are like that. I'm trying to think of examples of this. Places where you need to map over data and predict it. Okay, selected state is a classic example, where let's say you have a list and you have 100 rows, and you might model that as a single signal, but that'd be kind of wasteful. You might have a store, or what we call it, or the nested proxies, so that each property on each row could be updated independently. But the thing is, when you have selected state, usually it's ephemeral. It doesn't belong with your data. You might have your data in like 2 different views or 3 different views. You're not going to put like an is selected on each thing, because each one might have their own is selected in the different views. You might have the list here and the list here, and they have different selection state. So you have this zone where selection might be a single value, like row 1 or ID 22. But how do you efficiently put it in? Because if you have a table and you can picture you have is like selected ID or something, you're going to check that on all 1,000 rows or 100 rows. So when it changes, it causes some kind of update in a for n number of rows. I had this problem when I was building data grids at that photo company. So I was like, I started coming up with these like special case scenarios where I was like, is it possible that when you change the selection from A to B, you only run the computation in 2 locations? And I came up with really complicated ways to solve this in Solid 1.0, but one of the works that I've been doing in Solid 2.0 is generalizing that into a single primitive. And the idea is basically, we call it a projection. I don't know if it's the right term. It kind of projects out the data, but it's a derived proxy or store. It's this ability to take in a source and then only update certain properties and then have those independently notify out. And you might be like, okay, well, what's the difference between using like an effect to write to a store? But the key important part in our reactive systems is that data is derived, because that's what gives us consistency. When you have an effect write to a signal, you broke the chain. You don't know that signal is dependent on that other signal that triggered the effect. You no longer can trace. We can't guarantee things run once. You can have ping-ponging happening. You have to change the pattern so that it's derived. And I know this is getting kind of technical, but the end result is we've been working on these derived primitives that are basically an alternative to doing data diffing, which is going to be really powerful when you consider systems that have fine-grained changes coming on the inside and fine-grained transformations on the outside. Examples of those kind of systems, sync engines, WebSockets, places where you're doing these patches coming over the wire. What happens today with those engines is they know, oh, hey, I need to add this row to my local database. They know the patching, but then they just rematerialize the whole view, and then that one data point will React goes, okay, well, I don't know what's changed. Let's rerun all the components. Let's diff it all, and then let's figure out what changed. With these primitives, it's possible for the server to basically communicate the one thing that changed, have that propagate through all the way to the one thing that updates in the client, and have no components rerun. We've already made models of this. We made a Trello demo in Solid using Solid Start, where we kind of modeled this kind of behavior pre this primitive existing kind of special case to it. But this is an ability that I just want people just off the shelf to be able to do with Solid. Yeah. So this is this create projection, mutable reactivity, solving the selection problem, solving the propagation. This is one of the big topics. And arguably the second most interesting thing that is coming.
You said like, you cannot like just leave me hanging like this now. What's the most interesting then to you?
Async.
Async.
And this is probably the most controversial, but I had this idea a while back. I'm very inspired by React. And React has done this amazing job of things like suspense, but people kind of look at it mechanically and they don't always look at the implications. The idea with suspense is about this idea that when you have something async somewhere in your tree below, we don't really care what it is. The code will run, it will try and run, and if it fails to, it will show a fallback, and then when it's ready, it will render it. Now, there's lots of ways to mechanically do this, and we have suspense in Solid 1.0. But the key thing that React did is that they basically started doing this thing where they throw promises, which is this kind of funny mechanism, but it meant that your user code never errored. Like when things are undefined, you could write your code as if it was always defined. So if you had a user and you want the name, so you have user.name. Because when you tried to access user, it would never get to like name of undefined kind of problem. So you never had to do null checks. So essentially, when you look at the type of your async, it wasn't like essentially promise of user. It was just user. It would always be there once it's resolved. There's no undefined. There's no thing. It was just non-nullable. Essentially removing what we call coloration out of our async. You don't you don't need async functions. They do use that in a server components on the server, but generally speaking, you could just they have a use keyword in React, so you could just use this promise, and then essentially out the other side you just get the thing with no color, nothing. And there's a fancy term in academic world like algebraic effects and all this stuff. which
Fancy.
is it's craziness. It means something to someone. The same people that monads probably mean something to. But this concept is really powerful because from a UI standpoint, it it removes the time element out of the stuff. You can just like write your code. The only problem was with a re-render model like React has, it's very hard to, like, if you fetch something, like use fetch this, if the whole thing's going to rerun again, it's going to fetch again, and then it's going to fetch again. How do you keep it from like infinite looping? Well, you can hoist up the fetching, which is always a good idea, but you can also kind of, the way the React model, you couldn't just use their built-in memos and stuff. Like you'd have to kind of come up with a caching mechanism and all this. And I was like, that's kind of unfortunate because what ends up happening is people, when they like push the stuff up, they end up having to pass promises through their tree. So it's not colorless completely anymore because now your props need to accept either the value, like your components need to change to accept promises. So I know this is a long-winded explanation. So I was like, what if our reactive primitives could do this colorless thing, but restrict it to the reactive scope? And what I mean by that is, what if you got back a signal that was always user, not non-nullable like that? And that way, what you're passing through your tree is still signals. Like it doesn't matter if you fetch low or fetch high. If your model doesn't re-render, like Solid's model doesn't re-render, when an update happens, we'll just trigger the reactive primitives independently without re-rendering things. So you don't have that caching problem. And if things are up high being passed through, well, we're already kind of hiding the passing of signals in Solid. Anyone who doesn't know, we always tell you to execute the signal on leaving, like pass the value, but under the hood, we're actually passing a function or a getter. So the way Solid works, you're just using values and you don't have to worry about like explicitly passing signals, but you are passing signals through your tree. So if we turn this async into signals, essentially, we can get the benefits of the colorless system where things are non-nullable without rerunning components. And what's really powerful about this is because we're not component level, we're not like React where you're like, use this component subscribes. It's where it reads. It's non-blocking. It's non-waterfall inducing because if you read something, it can pass through a component without re-rendering that component, without freezing that component. You can pass the signal all the way through. Unless you're like saying, I'm waiting on something async, like if async fetch async thing underneath, unless you're like literally doing that, if it's passing down, you're not going to cause a waterfall. Even if it throws, we don't throw up the whole tree. We just throw to the closest independent reactive piece. So people get on our case a lot about, and this is more the React crowd, about the fact that like, signals are special, they're these special data pieces. It separates the rendering from the data. But this is a place where it works really beneficially. And I mean, it's hard, I guess, of it to explain it for people, but when you see it, it's incredibly powerful because you have this system where you can just, have a primitive like create async or whatever, and just have a promise, and then write your whole tree as if async doesn't exist, and then have it just work. Like never be null, and it doesn't waterfall. This is a huge game changer. That's what I was trying to demo in the stream, how we don't waterfall, how it parallelizes the fetching, how you can just, it's TypeScript doesn't have to worry about the checking for nulls, which is always like a pain with signals. And the benefit is that with a model like this, everything's derived. That's what I was talking about, which is like this idea that it passes through the tree. We have incredible superpowers. The other thing that I was demoing on that stream is when we catch async, we can also catch errors in the exact same way where it passes through the tree granularly. So I was demoing something really kind of cool where an async request would error out and show an error boundary. But because the rendering and the data are kind of separate, when we collect the errors, we know what part of the tree errored out. So if in the future it became unerrored, like you changed that signal state and it triggered it, it could automatically resolve itself. Or if you have the error boundary and you're like, I want to retry, even though it's lower in the tree in the view, when it goes to try and re-render and read that signal and it goes, I've been errored in the past, it can just pull its dependencies through. And because async is derived, it can actually refetch based on the dependency graph, even though the retry is down lower in the tree and the data is higher up, it can fetch through. And again, these things demo better, but essentially there's this incredible power here that's only possible because of this sort of system. I was looking at it, I'm like, how do you write this in React? Or like you don't. But the thing is, this is like, for me, I feel like we're just scratching the surface here. Like that self-healing error boundary was something that I realized kind of as I was working on it. And I think the challenge has been, until now, I've spent all my time trying to prove that we could do the same stuff that you can do in other frameworks, other libraries of this approach. You don't need to use a VDOM. You don't need this. You can do the same stuff. It's performant. It works well. I spent almost no time working on what we can uniquely do that you can't do in these other solutions. So I think now, especially with other libraries like Svelte and Vue kind of picking up the same pattern, we're in for a kind of renaissance here in terms of what's possible in the way we look at front end. That's what I'm excited. These are but a few examples. I think async is really, really powerful. I think this idea of colorless async that I'm talking about completely changes the pattern. It makes it like incredibly easy to take existing type systems, things that, maybe people like patterns like React Query or TanStack Query or whatever. Just take things like that where you have this simple data fetching primitive, maybe you have your own caching stuff, and just kind of stick it on the page and have the framework be able to embody these superpowers. I said, like being able to be self-healing, being able to automatically handle suspense, automatically handle streaming. And basically, because you have a primitive for it, any third-party library benefits from it automatically by using it, by composing on it. So like you basically are giving the superpower to third parties. So like this is one of those things where it's like, you guys just gotta wait like 6 months or like to come out to see the impact of this.
Yeah.
But I've already seen the potential here. It's very, very powerful. It's why I'm not that great at explaining it, which is why that stream took 5 hours. But it is very, very powerful stuff when you start changing the fundamental nature of what you understand to be true about async or these kind of problem spaces.
It really sounds like a fundamental shift in how you architecture data flow basically throughout an application.
Yeah, we hinted at it a bit in Solid 1.0. There were capabilities there, but this like smooths out a lot of the rough edges and it just like reduces the number of pieces needed. That's what I really wanted to streamline. I wanted to make it possible that like there's a model that felt native. As I said, we're not just imitating other solutions anymore here, in innovative ways. We're actually innovating into new space.
And that's actually one of the things that I wanted to mention earlier, like particularly like from the Angular perspective, Signals didn't really bring anything new to the game from like a developer perspective. It's just the way that you were able to write application, the same kind of logic now was so much easier and so much more comprehensive. So from like a developer, I think that's a part that it gets easily missed in that discussion around Signals. It's like, because it's, let's be real, it's often like, oh, it's so performant. The thing that I like about Signals is it's a model for how data flow that is very easy to comprehend compared to like other reactive primitives like observables, where I've spent years trying to explain that to people.
Yeah.
Whereas when it's like Signal, or it's like, yeah, it's very easy to like, okay, yeah, I get it.
It resembles some kind of written language. I kind of noticed this pattern before, even though React hooks are not the same as Signals, for example.
Yeah.
The language is very similar. This is why Vue and Svelte get a lot of complaints where they're like, you're trying to make it into React. It's like, no, this has nothing to do with React. But it's because like observables, you have this one really powerful concept, like this like stream observable thing. And then you have a whole bunch of different operations, like, I don't know, 50 different operations, ways you can combine them. At different times. I think at one point they shifted like almost 200 and then they scaled it back down. And, so there's all these different operations and it's all like it always felt very mathematical to me that like you to know all these things. Whereas what's interesting about the Signals approach is because it more resembles language. You could argue that in some cases, because the linking is automatic, it's less declarative for like the actual like forking and merging. But the actual graph is still very declarative. But like you get to write code in terms of what it depends on directly. So it's like spreadsheet cells, and this means that there's no operators anymore. So like all like effects are like, oh, I forget what it's a do or tap or whatever operation. So there's let's say there's one operator there. The rest of the graph is literally like every signal observable. They're not the same thing, but you could basically equate them. Every other operation is basically computed. Like there's one operator that handles, and again, this is not a pure, apples to apples comparison, but that drastically simplifies things, because what you're not like saying, okay, do I flat map before I merge and then zip? You're like, oh, I just turn this value into this other value.
Yes. I'm very curious to see how the compositional aspect of Signals 2.0 play out, because that's always the thing where I like RxJS, where it's like, oh, I have those 70, like a drag and drop, for instance. It's like, it's so easy in RxJS where it's like, if you write it in a more imperative approach, you're like pulling your hair out because it's just like a mess.
I mean, and Rx is still arguably the best for those kind of things. Like that whole thing is a transformation on an event. And I feel like, it's funny because one of the guys in the core team and the community dev, he made a Solidus events library, and it's a very
oh yeah, I saw that. Yeah,
it's kind of like obviously there's stuff like Rx out there, but he really wanted to play further on the interop between events and signals. Obviously, like we have built-in primitives. I know Angular does as well, but like he was like, is there more space here to kind of do that? Because some problems are better represented as events. He does a lot of WebSocket stuff. He does a lot of like server signals, kind of like real-time stuff. So like it makes sense why he's focusing on this area. So, but yeah, I mean, I think it's important also for people to understand that like signals and Rx stuff it does have its own place and has its own value. I think what's interesting is there's a lot of places where out of necessity we were using Rx and Angular, like where like in terms of like you're like, okay, I want on push, I want the ability to do more granular updates. Now you're on Rx, where a good chunk of those problems would have been better faced by something like Signals, something that gives you synchronous guarantees in terms of like synchronization and stuff. So yeah, I mean, and it turns out that maybe it's been my opinion, and I will see how Angular goes, that like actually 80% of the problems in UI space are actually on the Signal side, not on the Rx side.
100%. Easily agree.
Yeah.
Like,
so
I like to joke that RxJS and Angular applications is the only thing that is over and underused at the same time, where people just don't use it right and therefore create like those utter mess.
Yeah, I had like this saying that I used to say. I mean, I don't know if it's good, but I used to say like that RxJS is like the duct tape of the web. Like you need it sometimes, but it's like you don't necessarily be the thing that you want to like, because it can like glue anything together, but it's like you don't necessarily want to be reaching for it right away.
It's also, RxJS tends to be very contagious, where it's like you start once with it and everything has to be an observable now, and you're like,
Yeah, I mean, to be fair, most reactivity libraries have that characteristic. So it's funny because I talked about colorless async. Well, in a sense, we can pull off colorless async because everything's already a signal. Do you know what I mean? So we don't need async functions, but we have basically signal functions.
But the constraints around signals are not as impactful as the constraints around observables.
Right, because one of the interesting things about signals is at any given time, signals don't care about time as much. They're like, at any time you can ask for the value. Like you can exit out. You can just be like, I am done. I am out. There's no chain sequence, whatever. It's just like that's the difference actually with like computed values, or we call memos in the middle, is unlike the operators, is like they have to always have the realized version of their value at any given time. But it means that they're always escapable. They're always like, there's every point in the chain you can just escape off. You can just bail. So in that sense, yeah, they are less obtrusive. But on the other hand, you'll find you are changing everything into signals because everything needs to be reactive. Everything needs to track everything,
Yeah, that's true. I'm really curious to play with that because it sounds really interesting. I'm also really curious to see how it plays out, because before that it's very easy to Angular developers to explain. You use signals when you have static value and it's synchronous, and you use observables when it's asynchronous. That boundary gets now a little bit like blurry.
I did look at the Angular. They have a resource proposal, which is aptly named. Solid 1.0, our async is called resources, and it's not identical, but it's very, very similar to the current proposal. It's interesting because I said in Solid 2.0 we were actually discarding that for a completely new model, but it is. I think already you will see. I think people should get on it. This kind of approach is already a huge step up. The thing is, the reason RX still fits into it is, how should I put it? Signals don't care about time or care about async. So they're still not the right place to do async, but you need a way to bring async into the system in a way that that the synchronous system can understand. And that, like, if things aren't ready, it can know and influence it, right? So like, From that perspective, when I talk about async, even this async work I'm doing in Signals, I'm not saying like should be handling all the async chains that way. I think the async chains belong outside. There's an interesting example someone gave me the other day where they had a promise return async iterable, and then basically we have really incredible serialization powers on our server functions, our use server, so to speak, and where someone could like basically have a server function, make a request, return some data, and then return a stream over the wire, and then like feed it in. And the solution in Solid 2.0 was actually use create async, or which our new async primitive, to get the promise from the original request, and then feed that data into a second create async, because our create asyncs also support async iterables and streams. So it just used one to handle the request, and then fed it into the second one, which knew how to handle the stream. So like, if you see that the actual chaining and everything's happening on the outside, and then inside we just have a way of converting the value and even the nested value into signals. But generally speaking, all the wiring and piping of the async stuff still belongs outside of that domain. We just need a way to say, hey system, value ready, not ready. And then we can do suspense and we can do all other interesting behavior. So async's very, very important, but only because it is on the edges and on the boundaries. And I think there is some value of why the primitives are valuable is the derived aspect, closing the gaps, understanding that a source can trigger something async, and then the async can come out the other end. Even though technically these are disjoint because of asynchronicity, it's interesting for the reactive system to treat it almost like it's not async, so that it understands like in and out, because then it makes it part of the data graph. So this is good for, as I said, all the consistency guarantees and stuff. Like we know from the graph shape what depends on what. We can keep the chain going all the way through. And I think this is the kind of mental shift that's coming with these primitives. But as I said, like there's so much that's just like below the surface here. And a new feature with Angular coming out. I believe they call them linked signals. It's funny. We don't actually have this in Solid 1.0. It's something I proposed like back in 2021, and I just didn't like. I wrote an article about it a few months back. We haven't actually got to release it yet, but for people a little bit more on the tech nerdy side, what that is it's actually a higher order signal. The trick to the mechanics of a linked signal is it's a computed value that contains a signal in it. So essentially, so that it's possible that when the computed part changes, it replaces a new signal, and that way the signal is read-write. And because of the way this chains and composes, it's completely consistent, because the read on the outputted linked signal is actually a read of both the computed and the signal. And then the set only sets the internal signal, and then the reactive expression re-triggers the whole thing. So it's like, it's very interesting. Like, this is one example of this sort of higher level composition. I think there's a lot more patterns to be found in this sort of zone, as long as there's like the baseline primitives. That's why I create projection, like the async store proxy deep nested thing for derived. I'm adding the equation because I'm interested. I mean, we have it in 2.0 primitive. I don't know what the use case is. We have a writable derived store as well, like the proxy equivalent to linked signal. Yep. So like, but as I said, this is only one sort of zone. I think this kind of composition is interesting right now. Obviously, this is a research nerd thing for you, the developer. Generally, don't worry too much about this. It just means, though, that there are really powerful primitives or patterns that can exist out there, kind of potentially just under the surface in terms of describing stuff. As I said, our biggest challenge as framework authors is coming up with ways to allow you to easier write your code in derived ways. We want to see the dependency graph, because the more we see the dependency graph and we don't break it up with things like effects or whatever, the more optimization we can do, not just on performance, but like in terms of like raw performance, but in terms of like hydration, or in terms of like what JavaScript code needs to come, or just understanding what needs to rerun. So I don't know. It's an interesting world to view everything as data flows, but then like attempt, which is like the benefit of RxJS arguably, but then attempt to give the developer experience something that is much closer to just like localized, simple value logic.
Right. Is some of that work that you put out there with Signals to going back into the Signals TC39 proposal? Or is that still a little too early and just happen to happen too much in parallel?
Yeah, I mean, people want us to base it off that. It's potentially there, but as I said, the challenge is and we're getting close to the point where I could probably make a call on this, but the TC39 proposal really is, Signals 1.0. Like it really is the most baseline thing. It was not the 1.0 that like I originally knew, but it's how we've come to understand what the baseline Signals implementation is now.
Right. It's like the most basic that works mostly across all frameworks.
Right. And the challenge there is, because of all the additions, I don't know how much we're benefiting from that layer, right? We're seeing things like alien signals highly optimize that lower level layer, to the point that you're kind of like, do I use the TC930 proposal, or do I just like try and add stuff on top of alien signals? In our case with Solid 2.0, ours was built on reactively, which is a little bit older than alien signals, but it was at its time the fastest approach, and it inspired the other solutions.
I meant it more the other way, though. Are you trying to add the async aspect to the TC39 proposal?
No, I can't imagine. I mean, we aren't even trying to add effects to the TC39 proposal. I mean, some people are probably trying to add effects to the TC39 proposal, but there's too many, like scheduling. What I'm saying is we're trying not to add, I said effects, but scheduling. But I said there's 3 parts. Everyone agrees on part 1. Frameworks even don't agree among themselves on part 2, like the scheduling part.
Okay.
And ownership, I mean, it might be interesting. I'm starting to think that ownership might be actually more universal, like that might make it in. Mm-hmm. But if we're not talking scheduling, we're not even getting to async yet. So yeah, this stuff is tricky. It's still evolving. As I said, there's so many new possibilities here. I'm glad that the initiative's in place. Like, I'm very excited about TC39 from the perspective of like, I want browser debugging. I would just love it if it was just like really, really nice. Like this is the thing. For me, it's all about like that aspect, because like, isn't it so cool? I mean, you could like 7 or 8 years ago, I don't think you could do this, what you can do today, where you could, if you have a call stack and you're debugging and it goes through an async await, like you literally can just like trace right through. You're just like, okay, code before the wait, code after the wait. You see the call stacks all the way through. The thing is with Signals, there's that detachment, right? Because you queue on a bunch of stuff and then you run a bunch of work, or you progress. Like, because the way Signals work is they notify change and then they pull the stuff that actually changes down the line. But it means that the distance from in the code where you actually do the write to where you actually run the specific thing is so detached, because it goes through 2 different cycles. You can't really put the 2 dots together. Wouldn't it be amazing that if you're debugging like a computation or a side effect and you got a breakpoint in there, the call stack is like takes you all the way up to the signal, right?
Yeah.
Like that's the kind of thing that only happens either by something like the TC39 proposal, or like something like Replay.io. They were doing cool stuff like that for React. They had React core developers actually working on Replay, but where you can kind of come in and like use browser instrumentation directly to be able to do this. Like you need that low level in the browser to pull this off. So I'm very excited for TC39. If like that benefit comes to fruition, then yeah, definitely interested. And I think if the performance is good, kind of getting that baseline into other signal libraries to form the foundation. But in terms of like trying to decide on these things, this is still wide open. It's funny, like when people try to get JSX into the browser, I feel like this is even more of a long shot to get more of these higher level features in. We're not there yet. We're still learning. These things are still evolving. It's very hard to picture after all this time that that's the case. You know, as you said, back in 2016, 17, everyone's like, oh, you know, we're pretty settled. Things aren't changing much. I don't know, inadvertently, I feel like the work, you know, at least started with Solid, 7 years ago, kind of thrown a landmine or grenade in this whole thing. And now everything's up in flux again, where, you know, we are discovering new patterns and new capabilities, which is exciting.
I look at it as a very net positive thing, though. The way you phrase it sounded very much like, well, here's those grenade for your code base. Good luck with it.
Well, it's just that people, there's a certain desire. JavaScript's always gone a bad rap as being kind of like immature and stuff's always changing. And I still see it now. Like I work at Sentry, we do debugging, we do monitoring. My boss, David Kramer, I fortunately get to work almost like directly for him. He always has issues with JavaScript frameworks because they're always immature. He's like, why is the tooling so bad? Why is there no middleware? Why are these like frameworks not at the same level as like, you know, Rails or something like? And it's because we're always chasing after like these patterns, primarily client first, and then building them out. Like even the best of the JS frameworks like Nuxt or Next are still not at the like on the rail, like on that side as far. And you could think that they're working towards that direction. They might be, but usually what ends up happening is like multi-platform support, like for serverless or some other like newer tech thing, always prevents from actually getting all the way down to like, you know, Express is still very stable, very production ready. For like a pure, like you can see my boss, like from a pure that standpoint is very much like, you know, just use Node, use Express. But like the thing is, JavaScript there's been this desire for things to stabilize. I think that's part of why React's had such a stranglehold on stuff. Even if I think React's unique and has a lot of really good ideas, which is why it deserves to exist and why it's out there and it continues to propagate and improve and, you know, push the grounds. But you could say that like everyone else has landed on a different approach. And why React is still so much more popular when everyone else has disagreed or gone a different approach, it suggests a bit to the thing that people just want what's stable, just wants what works. And they want the change to stop or slow down. I get the brunt of that a lot because I'm, as I said, myself, our community is always a force of change. So like, that's why I talk about something negatively, because I spent my whole work positively in that space, pushing things forward. I feel like sometimes it does feel like there's a lot of natural resistance to that.
I get what you're saying, and I get where this view is coming from. But on the other hand, like JavaScript code that ran 10 years ago still runs in the browser. So you don't have to chase this latest. It's more like, I feel like JavaScript developers are much more concerned with general developer experience. Whereas like I did Rails like 10 years ago, and yes, while like this whole batteries included aspect is super nice, like some of the patterns that you have are just garbage comparatively. It reads very nicely, but it's still a shit ton of code comparatively.
Yeah, I mean, it's one of those things where like people have those like different levels of like scale. Like at one point where you're like, oh, does the performance matter about, you know, in these JS frameworks? And in a lot of ways, like it doesn't at the micro level or whatever. And I've sometimes, it's interesting to see on the other side that these very back-end oriented kind of people, you know, perspective going like how much does this front-end stuff matter, right? Because I've gone in the past going as far as saying that if you're not running JavaScript on your server, you're doing a disservice to your client if your app has any degree of interactivity. Like, don't get me wrong. Like if you are primarily doing like pre-rendered, static, mostly or like not interactive. Like it doesn't have to be static. It can be generated at runtime, but if it's not very interactive, then like, yes, go for it. But it's like, it's just because by running the code on both sides, that's how we can reduce the amount of JavaScript bundles, how we can reduce the hydration costs and all this stuff. Like if you have a heavy client, Rails plus Stimulus doesn't scale. HTMX does not scale. Like it doesn't actually solve the problem. And the challenge is like the JavaScript running on both sides is actually the way to get less JavaScript. It's the JavaScript paradox. And I mean, this is just one of those kind of zones where like you could still argue that none of this is necessary. Like we're so far off the deep end in terms of like expectations, and most apps are just CRUD apps, as you're saying, and just like this isn't necessary. I say it's not a zone that I worked in. I worked in social media. I worked in Twitter, Instagram type stuff. This is my experience. I think look, the guys who worked at Facebook, you know, like Meta, like I think a lot of the guys building these frameworks are working on maybe unique problems in the sense that their stuff is more interactive than the average website. So yes, maybe, you know, a lot of the stuff isn't necessary and it's getting oversold that way. But there's also something nice about like having arguably this one model. That's, I think, the thing that keeps on driving people. It's the fact that they think that there's like one solution for the web, which is tricky because the web consists of a server and a client, maybe multiple servers. And to suggest that there is one universal model is very ambitious. But I feel like maybe that's why a lot of cases why, you know, we're still working and evolving these solutions. I mean, it's interesting to me with the Signal stuff that we're finding new ways to just evolve even the client itself alone. But let's face it, the progress on the client side alone has actually, until recently, had actually slowed down quite a bit. Everyone's been focusing on SSR, been focusing on this client server handoff thing, and it's all in the goal of I think of coming up with a universal approach. And I think whether that's worth it or not, I mean, it remains to be seen. But until that's resolved, or until there's like enough progress there, we're going to see a lot of this iteration and this mess, because these are not solved problems as much as people want to like pretend that they are. They are not, because it just doesn't scale. And maybe that's fine for you, but big companies will continue to put money into it, right? That's why Marco at eBay was in service of that. Wiz at Google, you know, serving search and like Google Photos and stuff, was in service of that. And it's natural for things then like Angular wanting to kind of bridge the gap, because they're like, okay, why does Google have two different frameworks? You know, can we get the benefits of each? So like, it's one of those things where it's like, maybe we don't need all of this stuff, but like, if we can pull it off, if we can put them together, like, and have this ability to cater to the full spectrum, like, aren't we better off for it?
Certainly.
I don't know. Maybe not. Maybe the compromises, maybe the cost is too real. Maybe there's a whole other reasons. Maybe the complexity. Maybe there's like a million reasons why that's not the case. But people have to try, and that's why these things keep on moving forward. Because what do you do? Not try and solve these problems? Yeah.
Sounds a little bit like that guy that made Doom in TypeScript, where he was like, well, I just wanted to see it fail and it never failed. I always kept pushing and eventually it just worked. Slow as fuck, but it worked.
Right. Yeah. So, I mean, as long as we have the means to do it, like, I think there's really good innovation still coming out of it. It's a trickle down effect, right? As I said, Solid's work in Signals, probably majority of people aren't going to ever touch a Signal until they pick it up in their latest Angular release. But the impact of that over time is, I think, net benefit. So I don't see any problem with that. And I think you know, I don't know. It's always hard to make the argument against, because it's just like I guess there is a whole contingent of people that are like, we should just all go home and let AI start generating our sites and just like, you know, be done with it, you know, because they're like, you know, no one wants to train new models. Let's just use whatever is popular. It just like at a certain point, I do think people like want better things to improve. Stagnation is something that's real, and I don't know. I guess we're going to see how AI handles that, but right now it feels like the tool for stagnation, like in terms of technology. Like it's the tool that makes sure that the current stuff stays popular and things don't improve. And this is true within like React itself, for example. Old versions of React will outdo new versions of React. So like I think these things will change over time, but it is very interesting to see that the easier we make stuff, the more accessible we get, does that lower the bar, and is there still space? I think there is still space for improvement, but I mean, that's what I do. I look at how to improve
I was
things.
just saying, like, would be kind of gloomy outlook for you otherwise.
Yeah, I mean, that's the thing. It's like, that's why, like, maybe it's just my unique perspective on it, but like when you talk about all these big shifts and big changes on that side, and with these, it's like things are going to get better still, right? Like,
yes.
I hope so, because otherwise, I don't know what we're left with, yeah.
We already went way over time, and I'm sure you have other things to do than talking to me about the future of tech. Thank you so much for joining me today. This was really great. I always enjoy talking to you. You have a very unique perspective that is like to the outside world somewhat like uncommon. So I've always enjoyed talking to you. So thank you very much for joining me. And everyone, see you next week.
Thanks. Bye.